Hi, hello everyone. This is my second video about the XOR logic gate. Um, so now I'm building a circuit comprised of using two of the XOR logic gates, using the output from the first XOR logic gate to serve as the input to the next XOR logic gate. So just to recap, what I have here is a diagram of the a quad XOR gate. As you can see here, this is an example of the quad XOR gate. You can tell that this is the top by this little divot, this little kind of I guess half circle divot in the top. And this is the diagram. So this gives you an idea of what each of these pins go to. There's 7 pins on each side for a total of 14 pins. Let's put this here. This bottom pin here is ground. This top right pin here is VN, or your applied voltage. This is the serial number for the logic gate that I used. Like I said, it's an XOR gate. I got it from Texas Instruments. Really not that expensive at all. So just an idea, as you can see, there's 4 XOR gates on this logic, on this transistor. So this is the first one, these first 3 pins. This is the second one. This is the third one here, fourth one. And so what happens for an XOR logic gate is basically, here's the symbol for it. You have 2 inputs, A and B, and you get Y as your output, obviously. This is the truth table. So if you have 0, 0, A and B, then you get 0 as your output, because neither A nor B are activated. If A is activated but B is not, then you get Y positive. And conversely, if you have A as nothing, 0, B as 1, then your Y is 1. But in the case of an XOR gate, this is unlike an OR gate. If you have both A and B active, then you get a 0 over here for Y. And so the XOR gate is basically the exclusive OR, meaning that exclusively one pin has to be operational. So you can't have both, you can't have neither, just exclusively one pin has to be operational. So this is the circuit that I want to build. So remember, we have 4 XOR gates. I'm just going to use 2 of them. I'm actually going to be using the 2 set and the 3 set. That's not required, you know, you can use the 1 set and the 3 set, or the 4 set and the 2 set. It's just, that's what I used. So this is basically the kind of schematic that I'm looking to get out. I'm going to have 2 dip switches here. These are going to go to an XOR gate and give me this result. This result is just I'm then going to pass this result from the first XOR gate to my second XOR gate, along with an additional input, and then that'll give me my final result. And my final result will be an LED, so I can check to see what's going on with the circuit. So this is what I expect to see. So let's say I put a 0 and a 0 into my circuit, these 2. Then I expect this to be 0 as well. And then I have 2 kind of example sets. So let's say that I put the 0 Y is here. So remember, these 2 are the same, right? I'm just passing these through. So I have 0 here. Let's say in this example, my 3B sub 1 is also 0. Then my 3Y sub 1 would obviously naturally be 0. But if I pass through, I have 2A, 2B, and therefore 2y/3a is 0. But then in the second case, I put in 3 b sub 2 as 1. Then obviously my final result is going to be 1, because again, this is just a separate XOR gate. So I'd basically have a 0 here and a 1 here, which means I'd have just 1, 1, I guess, out of these two, and that would lead me to a 1. So this is a general truth table. I'm not going to go through all of them, but you can take a screenshot of this. So I want to go to the circuit and just kind of detail how I set this up, and then check to make sure it works according to this truth table. All right, let's do it. Okay, so here's my circuit. I just have an Arduino board here. That's just for power. It's hooked up through a USB to my computer. That's Madman. Basically, I'm getting power here. I have ground as white, 5 volts is red. And I haven't hooked up my 5 volts into my positive rail, but when I do, I'm going to hook it up to here. And then the ground is going to the ground over here. So I've connected both my grounds together from either side of the rail, just because I kind of need access to both of them. It's just more convenient. So this green right here goes from this ground to this ground, and makes both rails on either side of my breadboard grounded. So let's look more into detail into the circuit. These first two switches here, right here, these two, these are my initial inputs. So these two switches here, right there, are these two inputs here. All right. So as you can see here, the way I've hooked this up is all switches have to be attached to the power rail. You see here, this is attached to power. This one's attached to power. This third input here, this one, for this third switch, which corresponds to this input here. This one is also connected to power. So all my switches, all my dip switches are connected to power. By the way, you can get these dip switches pretty easily on Amazon. Pretty cheap. Come in a package like this. And they have, actually, like, you know, there's a switch for 10 dips. And you have 1 dip right there, 2 dips, etc., etc. You can just Google that. So anyways, back to the circuit. So I have all my switches connected to a power, as you can see here, all 3. And I have all my switches connected to either a gate. Well, they're all connected to, I guess, an input. So these first two, as I noted before, are these two initial ones, and they are connected to pins, looks like 2A and 2B, as you can see here. Let's see if I can get, you see they're connected to gates. Now remember that this gate here, this bottom one, that is our ground gate. That's why we have the white here connected to ground, right? And these two here, these 2A and 2Bs, these are connected to my 2 dip switches here, okay? And then these 2 dip switches are actually connected to ground as well through resistors. And you can use just about any resistance. I think right now I have, I want to say it's 220 is what I have, 220 ohms. But, you know, use your discretion. It shouldn't be that hard to figure that out. Then as you can see here, this output here, so this is my 2Y, is here. 2Y, as you can see, is here. 2Y. This is my 2Y here. It's the output from the first XOR gate that will pass through to my second XOR gate. It'll become the input to my second XOR gate. So this one I've actually connected to a resistor, and then I've connected that resistor to the input over here, which is 3A. So I've connected here. So we're coming from, we're coming from 2Y right here through this resistor, over through here, and then over to 3A here. There's just 3A here. So that's serving as the input to our second XOR gate. And then the input here is our second input to our second XOR gate, which is connected here, and again, like connected to ground through the resistor as I showed before. And then finally, the output for the second XOR gate, or this 3Y right here, that 3Y right there, that one is connected through a resistor. Let's see, this is better. See here, resistor to an LED. Remember that this LED needs to be grounded, negative terminal to the negative rail, positive terminal to the positive terminal of the resistor. So now let's check to see if this works the way we think it should. So first, let's try out our condition, this first line. So this first line here, we have 0, 0 for these first two dip switches. So 0, 0 for the first two dip switches. And then, wait a minute, let me get my camera into focus. And then let's turn on 1 for the second dip switch. So 3B. And let's see what happens. Do we get a light? Oh, we don't get a light, and that's because I haven't connected power. So let me just turn this off again, and let me connect power. Oopsie daisy, right? Okay, great. Now let's see if we can do this. So here we go. We'll turn this on. There you go. It's on. Now, what if I activate this first XOR gate, right? So right now we have a 1 here and a 0 here, so we're getting a result of 1. What if I make this into a 1 by turning either of these switches on? Well, in that case, we'll have 2 1s here, right? Because we have this 1 here, and we'll have a 1 here because one of these is turned on. And as a result, we'll get a 0 here, right? Because we'll have 2 1s here and a 0 here, which would be, for example, let's see. I guess that would be kind of like this case or this case. So these two cases. So this one is a 1, this one's a 1, so our result is 0. So let's see if we get that. Okay, we're just going to turn off one of these here. Or turn it on. And as you can see, now we have this one on, this one off, therefore this one on, therefore 2 on, and this final one is off. So as you can see here, it's working the way we would expect. Let's turn everything off again. Now let's turn this one on. Right, so we just have one of these on. Let me see here. Okay, so what's going on here? So we have this one on, this one off, therefore this one's on. Now we turn right here, therefore this one's on, and we have this one off. Therefore, this one must be on, right? So again, this is on, this is off, therefore this must be on. We can see here, this one right here, oops, pop that one off. This one right here corresponds to this one. So you can see this one's off right now. right?